Kruskal's algorithm for minimum spanning tree. The algorithm is given here and it will take a graph G and its weight as input, and as we seen in the generic algorithm, it will create an empty set A. Okay, and for each vertex that belongs to the graph, we will call the make set operation. Okay, so make set operation will make a set of every vertices in the graph. Okay, that is after this operation, every vertex, suppose the graph having 3 vertices A, B and C, every vertex will be an individual set. Okay, and I will explain why we needed this when I am simulating the algorithm. Okay, and now we will sort the edges of the graph in a non-decreasing order of weight. Okay, and then we will take each edge from that sorted list. Okay, and then suppose u and v are vertices of that edge. Okay, then we will check whether u and v are belonging to the same set using the find set operation. Okay, and if they are not belonging to the same set, then I will add that edge uv into the set A, and I will make the set u and v as a single set. Okay, so here we are using actually disjoint set, the concept of disjoint set union and disjoint set find operation. Okay, so if you don't remember that operation, or if you don't skip the disjoint set section, I recommend you to go through that lectures. Okay, so now next we will see the Kruskal's algorithm in action. Okay, so after calling the make set operation, every vertices in the graph will be a for single set. Okay, you can see these are independent or disjoint sets. Okay, they don't have any elements in common. Okay, now we will sort in the edges of the graph in a non-decreasing order. Okay, that is increasing order, and we will start with the edge having minimum weight. That is, we have to find the minimum spanning tree. Okay, so we will start the edge having minimum weight, and we will keep on adding the edges according to their weight until we form a spanning tree. Okay, so if you notice here, the edge HG or GH is the edge having minimum weight, that is weight is 1. Okay, so I will add that edge into the minimum spanning tree. Okay, now a tree is formed. Okay, with the two, we have now only one edge in the tree. Okay, and two vertices G and H is connected. Okay, that is when I call this operation find the set of U. Okay, so I will call find the set of U. That is, first I will call find the set of H. Okay, so this is the set H set. Okay, and then I will call find the set of V. Here V is G. This is the set of G. Okay, and you can see these are independent disjoint set. Okay, so they are not common. They are not, G and H are belonging to different set. They are not equal. Okay, then I will add this edge HG into my graph. Okay, my tree. Okay, and then I will perform the union of these two elements. Okay, these two vertices. Okay, so G and H will be united and it will form a single set GH. Okay, why we are doing is that this operation will help us to ensure that there is no cycle formed while we are adding the edges in the graph. Okay, I will show you when I reached that situation. In that condition, I will show you how this prevents the formation of cycle. Okay, now let us, the next minimum weight edges are edge IC and edge GF. You can add edge IC or GF, that is your choice. Okay, so here I am considering the edge IC first. Okay, so find the set of I. So I is a independent set, there is no element in I, and find the set of C. C is also independent set. Okay, so I and C are not belonging to the same set. Okay, so I will add the edge IC in the minimum spanning tree. Okay, now it is not connected. Okay, you can see these are independent trees. Okay, it's like a forest. Okay, but later on at the end of the execution of the algorithm, this forest will be connected to form a single tree. Okay, so now I added this edge into the minimum spanning tree, so I will unite the edges I and C into a single set. Okay, I form the union of edge I and C into a single set called as CI. Okay, now the next minimum weight edge is edge GF. It is having weight 2 only. Okay, so G is belonging to the set GH. Okay, and F is belonging to an independent set. Okay, so they are not in the same set. Okay, so I can add the edge GF into the spanning tree. okay, and then I will unite f with this set. F will become the element of the set gh. Okay, now this set having three elements f, g and h. Okay, now the next minimum weight vertex is vertex cf is there, its weight is 4, and vertex a b is there, its weight is 4. Okay, you can choose either cf or ab. Here I am choosing ab. Okay, I just choose an ab. Okay, you can, there is no specialty in choosing that. Okay, it's your choice. So I am choosing AB, and if you before that find a set of A is an independent set, and find a set of B is also an independent set. Okay, so they are not in the same set, so definitely I can add AB into my set of vertices in the minimum spanning tree, sorry, set of edges in the minimum spanning tree. Okay, now I will perform the union of these two independent set AB and form a single set AB. Okay, now the next minimum weight edge CF is having same weight. Okay, so find the set of C. C is belonging to this set CI. Okay, and F is belonging to the set FGH. Okay, and they are independent disjoint set. Okay, so definitely I can add this edge into my minimum spanning tree, and then I will unite these two sets together. Okay, CI and FGH I will unite. Okay, if you go through the lectures of disjoint set, you can see how the union operation is performed there. Okay, so now CIFGH everything together form a single set. Okay, now next edge with the minimum weight is the edge 6. You see the edge IG, it is having weight 6 only. Okay, now if you consider this edge, find a set of I is belonging to this set. Okay, and find a set of G is also belonging to the same set. Okay, so this condition now become false. That is, if the elements are belonging to the same set, then we should not add that element, because if we add this will form a loop here. See, there is a loop is formed inside this. Okay, sorry, not, there is a cycle formed inside this, not a loop, sorry. Okay, so I should not add this edge because I and G are belonging to the same set. Okay, that is why we are consider using this find set operation. Okay, so I will not add the edge IG into the my graph. Okay, so next edge with the minimum weight is edge HI. You can say HI is having minimum weight, but you can see I and H are belonging to the same set here, this set, the second set. Okay, so I will not add that edge also into the minimum spanning tree. Okay, next edge having minimum weight is edge CD. Okay, so C is belonging to as this set and D is an independent set, they are different set. Okay, so definitely I can add a CD into the minimum spanning tree, and I will unite D with this set, and this will form another very big set. Okay, so now after this the edge having minimum weight is edge AH. You can say its weight is 8 only, and edge BC is also having same weight. Okay, so here I am choosing the edge AH. Okay, because BC also you can choose, I think there is no issue, but I am choosing AH. Okay, so find the set of A is in this set, the set 1, and H is in set 2. Okay, so they are disjoint set. Okay, so definitely I can add A and H. Okay, and then after that adding this edge into the minimum spanning tree, I will perform the union of these two. So entire A, B, C, I, F, G, H, D will form a single set after the union operation. Okay, now if I consider this BC, this edge BC is the next edge, but find a set of B is in the same set and C is also in the same set. Okay, so we will not add this because it will form a cycle here. Okay, so I will not add that edge into the minimum spanning tree. Okay, so next edge with the minimum cost is the edge DE. You can say cost is 9. Okay, so find the set of D is in set 1 and E is an independent set. Okay, so I will add the edge DE, and then I will unite everything. Okay, now everything formed a single set. Okay, so you can stop the execution after this because we have added all the vertices in the minimum spanning tree and we got the minimum spanning tree, and the total weight of the minimum spanning tree is this one. Okay, but if you explore other edges, you cannot add those edges into the graph. Okay, but every other edges will create a cycle. Okay, So this is how Kruskal algorithm will work. Okay, I hope you understood the need of find set operation, and I recommend you to go through the lectures of disjoint set, because for this purpose only I have introduced the disjoint set.